Hey guys, welcome to the new video in the NFR playlist. Today we would be deep diving into availability. But before starting with the video, just think for a second. Do you really know what exactly availability means in system designing? If you do not know, don't worry. In this video, we would be deep diving from basic to advanced concepts of availability. This is the only video that you need on an internet to become expert in this particular topic. This video is coming straight from me. I am having decades of experience in engineering, in building systems. There is absolutely no fluff. There is no BS, just pure engineering. Let's get started. So first, before starting, in availability, what we would be looking into. So there are several topics that I would be covering. First is purpose. What exactly is the purpose of availability? Then there would be the terminologies that we are in day-to-day life we use for availability. Then how do we actually measure our system availability? That is the metrics that we are going to use. Then comes the strategy, how to achieve that. Then testing, how should we test whether a system is truly available or not. And then finally some real world examples that we would be discussing. My emphasis majorly would be to take as much a live and real world example as possible. Bank transactions. Let's say I'm stuck somewhere and I need to do a banking transaction. That is an immediate thing that I need to do. Now at that moment, let's say the bank server is particularly down and I am not able to do that particular transaction. So now what I can say is like bank server is not available for me. Second example, if you can see, like there is most of the time a flash sale is going on, and during flash sale we all know, and again like I am a big fan of sales. So during flash sale we all know like there is a huge bunch of requests that comes at the same time to our systems for purchasing that particular product. At that time, 90% of the time we have seen like the system or the server is down. Now at that time we can say like that system or the server is not available. Again, the best example is Tatkal ticket booking, railway ticket booking. So that is the particular thin moment at 10 a.m. or at 11 a.m. The Tatkal ticket booking starts, and within fraction of seconds, because the tickets are limited and there is like huge rush of people who wants to book the Tatkal ticket. And at that time, majority of the time you see like the system is down, the system is not available, you are not able to book that particular ticket when you want to actually book it. And when the system comes up, all the tickets are already booked. So this is the main purpose. Like availability means my system should be available for my customers when it is needed for them. This is the main important purpose of availability. If my system is not available to them when it is the need, then my system is of no use to them. What are the different terminologies of availability are? So in general, availability is having majorly two terminologies. One is uptime and one is downtime. What exactly uptime means? Uptime means the time or the duration when the system is truly available for me for doing any kind of an operations. Let's say in a month, the system is available 28 days out of 2 days. Or let's say in a year out of 365 days, the system is available for let's say 360 days, and of 5 days, the system is not available. So that 360 days when I can truly use that system for my day-to-day activities, that is, we call it as an uptime. How are we going to measure that? We are going to discuss that in the matrix. But this is what uptime means. Downtime, it is vice versa, or it is an opposite to that. Uptime, how much time your system is up. Downtime, how much time your system is down. Means your system is not available. Now there can be multiple different reasons for downtime. So one reason for the downtime that you can think of is, let's say I have a scheduled maintenance. Or else there is a bug in the system which brought my system down. Or let's say my system got crashed. Or let's say someone hacked my system. So there can be multiple different reasons because of my system is going to go down. It can be planned, it can be unplanned. This is what a downtime system is. Now again, downtime is having two bifurcations. One is a hard downtime and one is a soft downtime. Hard downtime, it means like my system is totally unavailable. I can't even fire a single request. I would be getting, let's say 500, server is not available and this and that, blah, blah kind of a thing. Means like absolutely my request is not at all entertained. This is called hard downtime. Soft downtime means, okay, my system is available. I am able to query the request, but it is not as performant as it used to be in the normal time. There is a delay in the request. Some request is showing some malfunctioning. Sometimes I'm getting a response. Sometimes I'm not getting a response. Sometimes there is a delay. Sometimes there is a flaky behavior. This is what the soft downtime means. So now we have completed with the terminologies. Now let's discuss on the matrix. So this is the matrix. Metrics majorly you need to understand is like, okay, how can I assure to my customer to whom I am providing a service like, hey, what is the uptime of my service? I need to give them some numbers, right? So how do we generally measure the uptime of our system? We measure it by these different four parameters. We can say my system is 99% available, 99.9% available, that is 3 nines, 4 nines, that is 99.99% available, and 5 nines, that is 99.999% available. You can see like there is no 100% because there is no perfect system, there is no 100% available systems out there. That's the reason we have this last as a metric like 99.999, that is 5 nines. Now what is the cost? The higher the availability we are going to promise to our customers, the more the cost they have to pay. So low availability, low uptime means let's say 99% to low cost. In this case, how are we going to calculate? So yes, yearly, if I'm saying yearly, how much time my system is going to be down? So out of 365 days, roughly around 3.65 days to 4 days, my system would not be available. So like it can be like around 360 to 361 days, it will be available, not for completely 365 days. Now, in which kind of an application this is important? Non-critical applications, this is perfectly fine. Infra complexity is simple, it is pretty low, it is easy to be maintained. Then comes the 3 9, that is 99.9% availability. Again, the cost is low. In the year, now instead of 4 days, it is like the time is reduced into hours. So now it would not be available for let's say 9 hours. So out of 365 days, you can consider let's say roughly around 364 days, the system would be available for your customer. Now, in which category standard SaaS-based products are there for them? This kind of availability is good enough. Infra complexity, again, it is low. Obviously, it is more than what our normal 99% is. But yeah, it is again like pretty simple to be maintained. It is not that big of a deal. Then comes the 4 9, that is 99.9%. And again, like from here, the system starts becoming complex. So now the cost is moderate. Now in the yearly, you can see like only 1 hour, roughly around 1 hour, my system would be not available. So out of 365 days, 364 days and 11 hours, most of the time my system would be available. Only 1 hour is there where a customer won't be able to use that particular system. Trust me, achieving this thing, if any system is saying they have 4 nines availability, like they have done a great deal, great engineering work if their system is supporting this 99.99%. Most of the systems, around 80% of the systems or 90% of the systems, stop here only. They don't go beyond that. And because like this is a highly available system, the infra complexity is medium. Then comes the final and the most critical 99.9999%, basically that is the 5 9. The cost is extremely high. Yearly down, you can see only for 5 to 6 minutes it is not available. So out of 365 days, 364 days, 11 hours and around 55 minutes the system would be available. Only for 5 minutes the system is not going to be available. So just assume, just imagine basically the kind of availability or the kind of engineering effort that we are putting for giving this much uptime to a particular customer. Category extremely mission critical, for example warfare, military operations, satellites and all those kind of stuffs are there where this kind of a mission critical availability is extremely necessary. And again, at that time when the system is down, they have already a backup plan for that. And this happens majorly in the case when it is a planned thing, and for that they already have a backup. Infra complexity extremely high to be maintained. Achieving this complexity is pretty difficult, it is pretty cost intensive. But then again, like if the application demands and if they are ready to pay, company has to deliver. So now we have completed our matrix part as well. Let's discuss on the strategy part now. So what exactly strategy means? So before strategy, let me take you to how exactly now we are going to approach. So first, what is the primarily focus? So my primary focus now here is basically two legs or two fronts I need to work on basically. So first is development and deployment, and second is failover. So when I am developing an application, I need to be mindful like, hey, my system should be available, and what all strategies I can use for during development time, so that like I can ensure I can provide at an application level the availability of my system. Then comes the deployment part, the infra part, where again at an infra level, at a network level, I need to consider, hey, my system should be available. Application is supporting, deployment and infra is supporting, both the things are happened. But still, like no system is perfect. There can happen like system is going down, there is a failure in the system, and now how are we going to overcome from that particular failover? That is the failover mechanism. So we should be ready like from development, deployment. But even if something mishappens, If there is a failure, from that failover, how are we going to recover? That is again like something which we need to plan earlier before deploying the system. So this two should be our primary focus: development, deployment, and then failover. Now let's discuss on the strategy part. So strategy means how exactly we are going to achieve the availability for our system. Because our focus is on these two legs, my strategy is again divided into these two parts. First, we would be discussing on development and deployment. Then we would be discussing on failover mechanisms. So from a development and deployment perspective. So first, from a development thing, we can think from an application. My application, when I am developing, I need to ensure my system is having a high throughput. Related to the throughput, related to the performance, how to achieve high throughput. Already I have a video related to the performance, related to the NFR. I have created in this particular playlist in this channel. Link would be in the description box. After this video, please do consider watching that if you want to understand performance in depth. But just to give you a gist, whenever we are saying application, we need to ensure like, okay, I should be able to send the response as soon as possible. My system should be high throughput, low latency. How am I going to achieve that? Caching, queuing, CDNs, asynchronous programming, event driven programming. All those things are very much critical when I am going to consider how am I going to achieve the high throughput and low latency system. How does these things achieve? Caching, queuing, and stuff. These things helps where like it is not a blocking call, it is a non-blocking call, or either I am reading the data directly from a memory. So trying to avoid as much network call, as much blocking call, as much synchronous call, trying to as much IO calls, trying to avoid all those. If I am avoiding those, my system is fast, my system is fast, my system is having high throughput. If it is having high throughput, I am able to serve the request faster. If I am able to serve the request faster, there is pretty less chance like my system would be overburdened by the request and my system is going down. This is first thing that we need to consider when we are developing an application. Then comes the second part at the database level. Database is very much important thing because database is the when where I am going to do an IO operation. The more the IO operation is there or the incorrect database schema or incorrect database strategy I have implied, the more time it is going to take for processing my particular request. And the more time it is going to take, the more requests I would be getting, the more overburden my system would be. The more overburden my system would be, the more chances of it going down. That is the reason we have to think properly when we are going to design the database of a system. What all things from an availability perspective we need to consider for a database? Sharding. Sharding, doing it in multiple different clusters. If my one cluster is going down, in that case, other nodes are there for serving that request. Plus, because there are multiple nodes, the request is distributed, less load on particular node, faster the response we would be able to give. Second, read replicas. There is a cap theorem. I would be having a separate video on that. Consistency, availability, and partition tolerance. Everything you can't have. You can't say like, okay, I want my database to be consistent and available and partition tolerant. Something you have to do a trade-off. Here what can happen is I can do a trade-off between consistency where I'm going to say there is going to be an inconsistent data, there is going to be the delay, and there is going to be an asynchronous communication between my master and my read replicas. But then my system would be always available for you to serve the response. Or else I can say my system would be consistent, my system would be available, but my system would not be partition tolerant in that case. So there is a trade-off that we need to take. But then read replica, how does it help? Again, it helps like more the requests I'm getting, more other servers are engaged in sending the response. My master is not blocked, my master is not going down, and it helps in writing the stuff faster. Then the caching, very much important. Caching, we all know, stores the data in memory. Getting the data from in memory from RAM is 10x faster than getting the data from IO. So caching is very much important. The shell data, the static data, the data that I know like is not going to get updated or is frequently going to get used, I would better cache it and get it from in memory rather than giving an IO call on a disk call and like increasing my latency. Eventual consistency, Cassandra, we know like high write throughput system, ScyllaDB. The more the eventual consistency we are going ahead with that system, if the system is okay with that, the less we have a dependency for having a synchronous write and getting a complete consistency across all the nodes, the less the time we are investing, the more the better and the more the faster output we would be getting. Asynchronous write, like we have this Kafka Connect, most of the time it happens like let's say leaderboard or other system that you are developing where you need to have a fast read write and fast computations you need to have, but you need to process that data rather than processing the data because again like writing takes time. So in that case, we think of doing an asynchronous write via let's say spinning a different thread who is going to do this background write job or writing the data on the Kafka, and then from that Kafka there is a Kafka connect who is going to parallelly write. So asynchronous writing means there is no synchronous, there is no synchronous, there is no blocking call, there is no blocking call, again the faster response. Then comes at an infra level, which is a deployment thing. At this thing like smart load balance. Yes, means like let's say my load balancer is just who is distributing the load. If it knows like okay, one of the server is not performing well, it is like not it is having high error rate. In that case, my load balancer is going to stop sending the response to that particular server. Then comes rate limiting and throttling. Every system should have this rate limiting and throttling policy. If not, my system would be overwhelmed with the request. More the request, more the breakdown of my system is going to happen. I need to do the load testing, stress testing. Again, we would be discussing that in the testing part. But the better we know our system, the good rate limiting and throttling policies we are going to apply. Because of that, less requests or only those requests which my system can serve, I would be allowing. And because of that, less breakdown of my system. Bulk ahead isolation. Bulk ahead isolation means let's say because and again like let's give you an example of a microservices. What we generally think is like we are having different microservices. Either they can be part of the same flow or part of a different flow. But let's say one component of my system is going down, one microservice is going down. Customer should be able to use another services. For example, during order placement, my payment service goes down, but customer is able to use the card service, the order service, the inventory service. Everything customer is able to use. Tenant based isolation. Generally, S3 or DynamoDB, most these kind of softwares or applications, they use this tenant based isolation. It means like okay, let's say S3 is there and multiple different companies are using S3. Now what would happen? Let's say Dream 11 and Paytm, these both the companies are there, they are using. Dream 11 is having a huge load, and it is let's say trying to put the huge data or huge buckets of the S3. Now because of that there is some issues going on, and because of that the Dream 11 tenant goes down. I do not want other tenants like let's say Paytm or Google who is using S3, they should go down. In that case, there is this tenant based isolation where a complete infra, complete pipeline, everything is set for that particular tenant. So even if it goes down, no other tenants are affected. Then comes monitoring and alerting, which is very much important part because it is all about the availability. We should be continuously monitoring the health of a system. We would be seeing how a system is performing, whether the error rate is increasing, whether the latency is increasing, whether my server is crashing, whether the request is spiking, and do I need to auto scale or upscale my new pods. All this monitoring and alerting is very much important. Then comes the multi-region deployment. Or let's say I am a person who is always like querying to my nearest zone, that is the Mumbai zone, and I am querying to that particular zone to get the faster response. Now what if my Mumbai zone is down? Should I not be using that particular service? That is absolutely wrong. So what I would be doing is basically depends whether it is high availability or not. I would try to keep it in two different zones or multiple different zones. I would try to keep that same application, same server, so that like if I am not able to request to this zone, let's say in Mumbai, I should be able to request in Delhi or in Bangalore, so that like my user experience or my operation should not get halted. This is called multi-region deployment that we are doing. Then comes the active and active passive setup. Active means let's say there is a huge load and I know like again I have anticipated this much load can come. So now what I'm doing is I'm keeping multiple different servers, so that like if let's say suddenly a request spikes, I would train my load balancer to use these different servers. So these are active servers. They are not actively serving the request, but they are there in the system for us to serve that particular request if required. Active passive, like let's say in the database, the database is that the node is there, it is not receiving any request, but as and when required, let's say one server is going down, one node is going down, that passive is becoming active and it is starting serving the request. This is what active passive setup is. Then the most important thing is deployment strategy. Deployment strategy, as and when time has progressed, we have came up with the multiple deployment strategies. Why? To have very less downtime and deploying it on the fly. So there are different deployment strategies, blue, green, canary, and whatnot. I would be having a separate dedicated video on the deployment strategy. But again, like that depends on an application to application, what we are promising to the customer, what problem we are trying to solve. Based on that, the deployment strategy is there. One size fits all is a myth. So now, from the strategy perspective, we have completed the development and deployment part. Now the next and the major part is failover mechanism. Let's say I have done all the due diligence, I have taken care development, deployment, everything is happened fine, everything. But still there is a chance my system can go down. In that case, if my system is failing, what should be my failover mechanisms? That is the next thing that I need to plan. No infinite retries. What exactly that means? Obviously we know like okay, let's say I'm not able to reach a particular server. Does it mean like okay, I'm going to continuously hit that particular server? Obviously not. There has to be a particular limit. Nothing is going to be infinity in the system, right? So there should be no infinite. If no infinite, no load on the system, my system is stable. If it is failing, it is failing, and that is perfectly fine. We should accept and we should respect the outage, and that is okay. We should not go ahead and push our system at that level. Like, okay, continuously we are hitting the request, and my system is going down. Because there can be the possibility, let's say there is a server is down and I'm hitting the request, and the next time or the next time the server is coming up and my request is getting served. But let's say what if there is an issue with my request only, and because of that every time you are going to hit, you are going to get an error. Does this mean like we are going to retry? No. So that is the reason there is not going to be any infinite retries. Then fail fast. If you have to fail at fast at first level. Let's say there are 3 different macro services. You are doing a validation checks and balances at the first service. If it is failing, if the request is failing, if something is failing, fail at that particular moment rather than pushing your request to different layers. And at that time we are recognizing like, hey, my system is failing or something like that. So if you want to fail fast, decline the request so that like it should be less burden on other systems. Then comes retries with an exponential backup. Like I said, there is not going to be any infinite retries, right? But let's say I am saying like, okay, I would be doing 3 times or 4 times or 5 times retries. That retry should not be back to back. Let's say, okay, I retried, I got a request, again I am retrying, I am getting a failure, again I am retrying, I am getting a failure. No, this can't happen. Or again, you can't do it linearly. Okay, after every 2 seconds, no. There has to be exponential backup, because let's say if the server is down, you have to give some time for that server to come. Correct. Or let's say your Cassandra, your infra is down, or whatever happens, you have to give some time for that thing to come up, right? So that is the reason there is an exponential backup. Let's say initially I am trying immediately and I'm getting a failure request. I will try after, let's say, 30 seconds. If I am failing, then from that I would be trying after 1 minute. If that is failing, I would be trying after 5 minutes. So this is an exponential backup. What it would benefit is, it is going to help us give certain buffer time for that system to come up and serve our request. Then comes the circuit breaking. Circuit breaking is again like one of a good design principles or design patterns. Again, we would be discussing when I would be creating a complete playlist on microservices design patterns. Circuit breaker is one of them. Circuit breaker means what? Let's say I am hitting a server. Let's say I'm hitting a payment gateway and my payment gateway is down. It is saying like a 502 and my gateway is down. Then in that case, because I know this particular request is failing, it doesn't make sense for me to give continuously call to that gateway, right? Because I know it is down. If I know it is done, why would I give a request to it? What I would do is I would trip the circuit. In that case, like, okay, I would have a failover mechanism, or I would have a fallback mechanism where, okay, I know if the circuit is stripped, if my requests are failing, I would just close that particular circuit. I would not allow the request to go to that payment gateway, but I would send some response, some temporary response or something like that. But parallelly, after some time, I would be trying to reach that particular gateway to see like which is calling like half opening of a circuit, where I would be trying to reach to that particular gateway to see whether that gateway is now up or not. If it is up, great. I would completely open the request, open the circuit and allow the request. If it is not, again I would be continuing with my own circuit breaking process. How this would help? I know if something is failing, why would I overburden that by hitting the same thing and expecting the same response? Then comes the auto healing part. Auto healing in KATS you have seen. Okay, if some pod is going down, automatically it is healed. How automatically it is healed? It is detected, okay, this pod is not working, this pod is crashing. It just removes that pod from that particular cluster and it just creates a new pod. This is called auto healing. So now we have completed with our strategy and failover mechanisms. So now this is how we are going to ensure like how our system is going to be available. Till now, again, like if you feel like some valuable information I have added which you haven't thought of or heard of previously, then please do consider liking and commenting this particular video. It really helps in growing the channel. Then comes the second last phase, that is the testing phase. As part of this testing phase, because now you are claiming like, hey, my system is available, but we need to test that so that like we shouldn't get surprises on the production environment. So now how are we going to test it? So there are different testing mechanisms. So like there is something called chaos testing that we would be doing. Then again, there is going to be load and stress testing, because system is going to fail when there is going to be load. Then what my system can handle. So I need to have that particular parameter. If my system can handle 100 requests per second, means it should handle 100 requests per second. I can't expect at the production some miracle is going to happen and my system would start handling 150 requests per second. No. If it can handle 100 requests per second, I would ensure like my system would be getting only 80 requests per second, and there should be other pods who should be able to handle that particular request. So let's say if I am expecting 1000 requests and I know 100 requests per second my system can handle, I can have 10 pods. But at the safer side, what I would do is I would keep having like, let's say 14 pods or 15 pods. In that case, what would happen is my system would never reach that threshold of 100 requests per second, but it would be around like 70 to 80 requests per second, which is decent. It would not first blow up my system, plus it would help have a better user experience. Then comes the performance testing. Again, like performance is important because I should be knowing how performant my system is. When we are saying availability, along with the availability, reliability comes. Again, there would be a separate NFR for that. But performance of my system, my performance under the load, it should not change. My system should be available to serve that same latency, same SLA, same SLI, same SLO that we have committed to the customer. So the performance is important. Performance testing is important. During testing phase only, what we would do is generally we try to introduce a bug, or let's say we try to, again, like a hypothetical example, pulling a chain and like pulling my electricity socket and seeing like what if my Cassandra is going down. Just again giving an hypothetical example, or crashing my particular application node log, or like let's say overburdening it with too many requests so that like it should crash. We are trying to recreate or regenerate such kind of situations. Why? Because I want to see if such kind of a situation happens in production, how my system is going to react. This is again important. That's the reason these are the 4 different testings that we would be doing, and ensuring like, okay, my system is available, truly available or not. So now we have completed with testing part. And now the final thing we would be discussing on real examples. So let's take an example of Netflix. Netflix is guaranteeing its system is going to be available 99.99%. That is the 4 9 that we have discussed earlier. So this is what it is guaranteeing, but how? And not only guaranteeing, but it has tested and it has ensured that his system is 4 9 available. How? By doing chaos testing. Then caching the response. Like I mentioned, like all of my in the strategy, all those things are like repeated only. By caching the response, by doing smart load balancing, by multi-region deployment, all those things Netflix follows. And because of that, and again, like this is just a limited information. There is like a lot more things that Netflix is doing. But the important thing is, because of all these things which we have discussed above, Netflix is able to achieve 99.99% availability. Then comes Amazon. Amazon is again like highly available system. If you have seen like during Big Billion Day, there was like there is a record of 69 million requests per seconds. For serving this many requests, the system should be highly available. How they have achieved that? So Amazon is highly available, but they are having some different strategy. They are doing multi-region deployment. They are doing asynchronous programming, event-based programming, queuing. All these things they are doing, async writing in the database, dynamic scaling, auto scaling. They are doing warming up the servers. They are doing load and stress testing of the servers to ensure like how much load my systems can handle. And because of that, Amazon is also ensuring like they are most of the time like 4 9 available. So this is what the real system examples are when it comes for availability. We have discussed on what is the purpose of availability, what are different terminologies, how are we going to do the measurement, like the metrics, the strategy, how we would be achieve that, how we are going to do the testing, and the real world examples. If all these things you feel like okay, something new you have learned to this from this video, please do considering liking and commenting this video. And again, like if you like this stuff, more similar kind of stuff would be coming in the future. So please do consider subscribing this channel as well. Thank you.